Hi, this is part of an in-depth series on the programming of Throw Rock, a video game I made recently. So, last time I went over what happens in between the double click of an executable and when the window comes up and the game starts. At least part of it. So I covered the part of what happens in my framework code to initialize my window and OpenGL context as far as Windows knows it, up to the point of returning control to my game code. So, we're not quite actually done with this, but just to stay focused, I'm thinking maybe today I'll mostly focus on the idea of user input events. Like when I move my mouse or click my mouse button or press a key or whatever, how that gets from the system to my game code. There's still a lot to cover. But yeah, so I was at the end of WinMain in WGL shell and calling target init. So in a STEM application, target init is sort of the first entry point. We went over all the details of that last time, but anyway. Once control has returned to my game code, basically the job of this is to do any post-configure setup and initialization, and then call shell main loop to return control back to shell, where control passes back and forth when user input events happen, or timers go off, or other things need to happen. So these two continue sharing responsibilities during their lifetime. So one important thing that I sort of neglected to talk about last time in detail is the window proc callback. So when I register my window class, I assign this thing lpfn windproc. This is Win32's Hungarian notation, as they call it. This is an abbreviation of the type of struct field. Long pointer to function is how that would be read. I don't know what a long pointer is. It's some old computing thing. There were long pointers and not long pointers, like when memory models were different. That was before the time when I was programming in C, so I never got to experience that, whatever it is. But anyway, it remains around in the naming convention. So window proc. I went over a bunch of callbacks and things, stuff I set up in, for example, register shell callbacks here. This is fairly similar to that. This is the Win32 version of that. So this function here, which I specified in my window class that I registered before I opened that window, will receive calls to this function quite frequently, basically every time anything happens that Windows thinks my program might want to know about. So it tells me which window it happened to. Shell is not a multi-window framework. You only ever have one main window. Right now, that could change in the future, maybe. But right now there's just one main window, and it's the only window. And yeah, you get a message which specifies what sort of thing happened, and a W param and an L param, which is a form of encoding of what happened. So my job in here is to check which message it is, using a switch statement or something, and respond to the ones that I care about, and the ones that I don't care about get passed back to Windows for whatever default handling it wants to do with it. There are some complicated nuances with that I'll probably get to here. So WM Paint is the message that happens when, by the way, if you wanted to know about things like this, msdn.microsoft.com is where I go. Let's look up, for example, WM Paint. Windows CE, that's not what I want. This search could be better. WinUser.h, Win32 apps, that sounds right. Just for example, this is the documentation Microsoft keeps. It's very well maintained, fairly readable. I have very few complaints about the way Microsoft keeps things documented. They do a good job. WM Paint message is sent when the system or another application makes a request to paint a portion of an application's window. Message is sent when update window or redraw window is called, or by a dispatch message. WM Paint, get message, peek message. Basically, what that all means is when this function is called by Windows, and the message is set to WM Paint, that means to me that I need to redraw the contents of my window. So that is my entry point into drawing. So when I want to redraw myself, I measure the current time using this function we've already looked at. If this is a debug build, I'm going to want to know about errors. Validate rect. Right, this tells Windows that what does validate rect do? You know what? Let's look this up. It's been so long since I wrote this, I've forgotten some of these things. Validate rect function validates the client area within a rectangle by removing the rectangle from the update region of the specified window. Yeah, so I think this is saying to Windows, yes, I've heard your message and I've updated this region of my window, so you don't have to consider that dirty anymore. It's funny I do this first instead of after I actually update the thing, but it doesn't really make a difference. Yeah, since I have an OpenGL context that covers the entire content area of the window, and I redraw the entire context each time I do a redraw, a pointer to a rect. If the parameter is null, the entire client area is removed. Yeah, I just say I've redrawn the entire window, so Windows doesn't have to worry about that anymore. Right, so I have some time measurement because when I call back to... Okay, yeah, so here's one of those things I installed with register shell callbacks. So I called shell draw func. Let's look at the implementation of that function. It's nothing interesting, right? I keep it in this file. Yeah, all it does is just assign the draw callback function pointer variable that's also accessible to this source file. Look at that weird stuff. Don't look at that weird stuff. Let's not worry about how that works. I don't even remember. I had some reason for this, and I don't know what it is anymore. Anyway. Yeah, so that just calls my if a draw callback is defined, because I guess technically you could have a STEM application that has no draw callback, but why would you have that? Anyway, if that's defined, then I call target draw, which is another very important function in here. That actually could be named anything. This naming convention is left over from back when I had to name it this, and it would just automatically link to that in my code and just call the function called target draw when this happened. But at some point I changed it to this callback system where I can just specify any function. Okay, so target init is like that. Target init is linked by name, and the configure function is, but only those are. All the other callbacks now can be named whatever I want. Anyway, we're at window proc here. We were at target draw here. So yeah, this function is called by shell, and when this function is called in my game code, I must... Right, yeah, that's the time at which it was called. That's the amount of time that passed since the last draw, or the amount of time that I should treat as passed since the last draw if I'm using this to measure time. Anyway, yeah, timing is very important for drawing. Animation just involves drawing things at a different position over time, so this is very important. It's parameters passed to the draw function that it needs to know about. It returns a Boolean. If it returns false, then it decided not to draw, like decided nothing needed to be drawn, therefore WGL shell doesn't need to like swap buffers or something. Oh, it doesn't even pay attention to the return value of this. Never mind. Okay, so return value actually doesn't matter, at least to the Windows implementation of this. Maybe some shells pay attention to that. This one does not. Okay, anyway, but yeah, this is game code. Let's first just go over what target draw's duty is. So yeah, it just needs to issue OpenGL commands and have a frame drawn by the time it returns, basically. So yeah, this is the last time at which I drew, so I'll know that for the next time measurement when I call that again, because this will be happening frequently, ideally 60 or more times per second. If I'm in debug mode, after each iteration of draw, I check OpenGL for errors and print something to the console if it has detected any. And that's my first sign that something is wrong. If my drawing is going wrong, then from there I can debug more specifically. But yeah, this is just a useful little error catching mechanism. Swap buffers. That is a WGL. Huh. Weird. It's a WGL function that doesn't have the WGL prefix on it. Anyway, yeah, so swap buffers just says that, like, you had this pointer to pixels that was the previously drawn frame, and I was operating on a pointer to another image that was not shown on screen. So then it just like swaps those two pointers. So like when Windows is redrawing a window, it just dereferences the pointer that points to the I'm simplifying this a bit, but in concept, this is what happens. It would dereference a pointer to an image of a rectangle of the size of the Windows content area, and then read all those pixels and send them to the display. So this just switches which pointer is being referenced for the Windows content. So that way I can do my drawing without a partial draw making its way to the screen if it is in the process of redrawing while I'm doing that. So I do it off in a hidden place. Then I say, okay, this is ready to present. Here is your image. Put it on screen when you're ready. This is also the point at which the system would sleep for a moment if vsync is on, and it would wait for a vertical blank interval in order to actually swap those buffers. So that's when that happens. Anyway, yeah, so as far as WGL shell goes, that's pretty simple. It leaves all the OpenGL calls and stuff to the actual game code. So we'll get to that. I'll go over this function when it's time. It's not quite time yet. So right, other things that the window proc can do. I think one of these is for live resize. So like it'll call WM sizing while I'm dragging and then WM size when I'm done dragging, or like if I maximize or something. Something like that. Probably there was a version of Windows where live resize wasn't a thing, like there wasn't enough CPU power to redraw at that rate, so you just see like an outline as you're resizing the window. I'm guessing that was a thing. It was a thing on other computers. Windows is old enough that it probably was. Yeah, Win32 is a very old API. There's a lot of vestigial stuff in it like this. That's just never quite gone away, but it's fine. It does a good job with it. If my window has resized, I need to ask Windows what the new size is, and then I make an OpenGL call, because OpenGL wants to know what size of thing it's drawing to. And additionally, I call the resize callback, which in here is target resized, which has already been called once during init. But yeah, if the window changes size during the execution of the thing, then I get to know about it. Oh. I should remove this. This should not be here because that's done by... Yeah, yeah. That's done by this. That's interesting. Okay, I have redundancy in here. WGL shell absolutely should not be calling GL viewport here. Okay? There, it's gone. Yeah, that is correct. It shouldn't be doing that. Okay. Anyway, resize callback. Yeah. So anyway, this thing's resize callback gets called. It does set its own viewport. In case that's called when a WM paint is not queued, that is the wrong file. It queues one up. Yes. So in game code, shell redisplay is the function that I call to say something has happened that necessitates a redraw. Let's see what that does. Shell redisplay just says redisplay needed equals true. Okay, so we'll cover that when we get to shell main loop. We're still in window proc. So right, that's resizing. Then we got mouse events. So we get a WM L button down, L button up, R button down, R button up, M button down, M button up. This API only supports up to 3 button mice. That's interesting. I have to use a different one if I want additional mouse buttons. And I guess I haven't had an occasion to want to get input from additional mouse buttons in any shell application, so I haven't implemented that yet. Anyway, yeah, so process mouse down, process mouse up. These are going to be complicated, aren't they? No, that's actually very simple. Okay. Right, so let's not talk about that. That's not important for this. It's further downstream stuff that I don't know. It's whatever. Set capture. Okay, the set capture function is important though. When I receive a mouse down event, okay, so let's once again use Sublime Text as an example. So mouse down, I'm holding the mouse button right now. Therefore, moving the mouse is now highlighting text. Now, Sublime Text needs to know when I've released the mouse button so that it can stop highlighting text. Normally, I don't get mouse down or mouse up events. An application does not get mouse down or mouse up events that happen outside of its window. So what I can do here is I say set capture on the window. That tells Windows, hey, I want to receive all mouse events for this duration. And when I drag and release the mouse button outside the window, it knows that's a mouse up outside the window, but capture is on, so I'm going to actually send that to you. Anyway, yeah, and this just reads the coordinates, x and y, out of the L param that was passed to the window proc, because they're both packed in there. That's just, location from top left to lower right on the screen. Keyboard modifier flags, that's a static variable here, I think. Those are modified when the window proc gets a message about it. We'll see that momentarily. And yeah, so that just calls the mouse down callback in here, which is target mouse down. And downstream of here, this processes it for game code. Right, not talking about that just yet, just how Windows processes this. Basically same for mouse up. I have some reasons I want to ignore mouse up sometimes. Let's not worry about that because it's not in evidence right now. Let's not worry about this. Actually, okay, I'll get to this, but not yet. Call mouse up callback and release capture. Yes, okay, that does make sense. So if this is the last mouse button, okay, so button mask is a bit field which keeps track of which mouse buttons are pressed. So this syntax here is C, bitwise operators. I do a bitwise OR with the existing thing in the button mask, which starts as 0. 1 left shifted by number of bits specified by button number. So if button number is 0, it's the left mouse button, 1 doesn't get shifted left, the bit is OR'd with the button mask. If it's button number 1, it gets shifted once, 2 is OR'd with that, button number 3, 4 is OR'd with that, etc. Anyway, yeah, that just keeps track of which mouse buttons are pressed, which I will want to know while I'm dragging the mouse around, so I know if this is a left-click drag or a right-click drag, or one with both down, if I want to handle that specially, etc. But yeah, then I also use it here to know when to release the capture. Interesting, so I always just call this. I assume it doesn't need to. Let's see if I'm doing something wrong here. Set capture. Why is this? This is cased wrong. I guess I want this. It's always like a few results down. That's my only complaint about this documentation. It doesn't give me the thing that I want when I search for it. Mouse over the capturing window, or the mouse button is pressed while the mouse is over the capturing window, and the button is still down. Yeah, okay. Only one window at a time can capture the mouse. Okay. Mouse button is down. If there is no such window, the return value is null. The window that had previously captured the mouse. Interesting. Only the foreground window can capture the mouse. Okay, even if the foreground window has captured the mouse, you can still click another window. When the release capture, the function cannot be used to capture mouse input. It doesn't specify whether I should have an exact match between my calls to set capture and release capture. Perhaps I should do that. Perhaps I should only do this if button mask is 0 now. Maybe, so that would look like this. There's no real harm in that other than the cost of one additional if statement. Yeah, it feels better to have those exactly balanced. So I'll call set capture exactly once when the first button goes down, whichever one that is, then release capture exactly once when the last button goes up, whichever one that is. Sure. Documentation doesn't specify that. It happens to work correctly on the version of Windows I'm running here, but this feels like possibly useful future proofing, or maybe it's a waste of CPU time doing that, but it's a tiny one, so I'm going to do it. Making changes here. This is fine. I haven't looked this closely at the shell in a while. Anyway, so where were we? Mouse down, mouse up. This just calls the same function with different button numbers. Mouse move, process mouse move message. How does that work? Process mouse move message. Sure, get the coordinates. If it hasn't actually moved, or if I need to ignore movement for some reason, don't do anything. Otherwise, process mouse movement, then ignore nothing. Mouse delta mode. Oh boy, there's a lot of stuff here. Good grief. Bunch of extra logic for different modes. So mouse delta mode is if I want to really capture the mouse and say, you know, like, for example, a first-person game controller would do this, where if I'm moving the mouse left, I don't want to be able to hit the left side of the screen and not be able to turn left anymore. I want to just be able to turn left forever in a circle, or right, or whatever. So that's when I would set mouse delta mode, which puts this into a mode where movement doesn't actually move a cursor. It just reports the amount that the mouse moved in that direction. So I just have some ifs for the way I want to report things, whether I'm in delta mode or not. Cursor hidden, right, yeah, and I can hide the cursor until the mouse moves, at which point I re-show it, which is where that is. But mostly just, if a button is down, I call the mouse dragged callback. If it's not, I call the mouse moved callback. Mouse moved, mouse dragged, both of these just do the game's handling of this, which is, we're not getting to that yet. We will, eventually. Or not, because throw rock, no, it does use mouse move for the for highlights and stuff. Okay, anyway. Mouse wheel. What the heck is all this? Yeah, okay, so this is simulating an actual mouse wheel if what you're using is a trackpad, like dragging your fingers across it to do proportional scrolling. Looks like I don't have fractional scrolling here, so right now I'm translating that to number of lines, like one click of the mouse wheel is that. That's something I've been meaning to change. Anyway, yeah, it just calls the scroll wheel callback. Throwback doesn't handle those, so let's ignore it. Key down and sys key down, two different messages for depending on which key was pressed. This one's very important. Update modifier flags. Why do I call that? Interesting. So when a key goes down, I poll the system for whether caps lock or shift or control or Windows key is down. What is this code? Okay, this is weird looking. Anyway, and set my own record of what the modifier flags are to my own constants here. This looks messy, but that's apparently what I had to do for some reason. Okay, so I pull for those 4 modifier keys, and those are the ones that I pay attention to. And then I call the key modifiers changed callback if there is one. You know, this is handled in here as all of those are. Oops. Window proc. I guess Windows as window proc doesn't send me a separate message for modifiers changed. Some operating systems do. This just gives me a key down or a key up. Anyway, yeah, so I just update that in there. This is weird. Yeah, okay, Windows keyboard events are kind of strange. I have to look ahead in the event queue to see if the next one is a WM character message and get the character code out of that if I want it. So this is, for example, you know, you're using a QWERTY keyboard and you press the upper left key, you get a Q character, which you can see would be written like this. If you're on an AZERTY keyboard, you know, you get the A character. So that's pulling this out in case the the thing using shell needs to know the character code and not just the key code. So what I work in is I use key codes that are positional. So the upper left letter on a keyboard for me is, what is that actually? Let's find out. These constants, I believe, are based on the USB HID specification. The same values are used there. So key code Q, 0x14, is the number that I get for key code when the upper left letter on the keyboard is pressed. No matter if it's Q or A or something else entirely, depending on the user's keyboard layout. One slight flaw with that, which I need to address somehow, and I haven't worked out a good way to do it yet, is that no matter what your keyboard layout is, it's always a US QWERTY key binding that's shown in throw rock in the settings screen. I had one person report that as a bug to me, and maybe someday I'll fix it. But yeah, so X, C, Z, R, those could be something else. But yeah, it's the position of the key in US QWERTY. So that's fine. It's fine for what I do with this, mostly. Anyway, I do need to translate that to a shell key code, which I do here. This function's ugly. I'm warning you ahead of time. This function is not pretty. Ooh. It calls one that's especially not pretty, but this one also is... Right. That must be the English US keyboard layout. This looks gross. So I get an HKL, which I guess handle to keyboard layout would be how that would be read. Win32 type, and I use that to map virtual key X, whatever that means, L-param, right shift 6. So that's how the key code is packed into the L-param passed to the window proc. Map VK, VSC to VK EX. You'll see EX a lot. It just means extended. Basically, it meant there was a function called map virtual key. Then in some later version of Windows, we decided we wanted to add more parameters to it or make it work differently. So there's now an EX version that new code will usually call and works a little differently. So if you see that, that's usually what has happened there. Another vestige of how old this API is. So there are up to 0x7f, 127 possible virtual key codes. So if you have a keyboard with more keys on it than that, then this won't be able to detect them. So layout, L-param, W-param. So then Windows VK to shell key code. Here's the ugly one. Gigantic switch statement. To write this, I ran a program that logged the key codes as Windows reported them, and just wrote down which one was for each key on my keyboard, and then translated it to my own constants. So it's not pretty, but it works. So yeah, here are just the numbers Windows reports, and here are the constants for the numbers that I want to report, and all those are defined in shell keycodes.h. Because I just needed a consistent base of reference for talking about key codes in game code, and for every operating system, usually these values are something different, like the number for the key that is the upper leftmost one on the keyboard, the escape key. I guess that's not necessarily where escape is, but it usually is. Happens to be 27 on Windows, might be, 35 on the Mac, or, 41 on Linux. I don't know what the values are. I made those up, but, that's the sort of thing. So each shell has a function like this that just translates one set of numbers to another. Some of them are special. 144 can be pause or numlock depending on what's in the W param. What else is weird? 13 could be numpad enter, or the enter that is next to the single quote key, or wherever it is on your keyboard. And I want to distinguish there. 191 apparently could be numpad or not. Yeah, okay, so left or right modifier keys, etc. Numpad 0 and insert share a key code? Why? Okay, so I guess actually that means that there could be more than 127 keys on a keyboard, because there are ways of overloading key codes from Windows, virtual key codes they call it, VK, with... Oh, I think there are constants for this. So this might have a Windows constant that is something like that. Yeah, there might be something other than just numeric literals that I could use here, but the numeric literals were what I had. They work. They're not going to change, so it's fine. Anyway, yeah, so that's how that is mapped. If I can't find anything, I print a warning if I'm in debug mode and just return to 0. Anyway, so we were at... I don't know, are we in the window proc? Probably. Anyway, yeah, so go through all that rigmarole to translate this to a key code that is in the list that I understand here, and then I can handle it. Where am I? There. You go away, I don't need you. If it is Alt F4, shell handles that specially, or if it's Control F4, because I use single window application, so Control F4 closes the window, Alt F4 closes the application. They're the same thing as far as I'm concerned. I do the things that I do on a user requested quit. Call my confirm quit callback if one is installed, and just call the exit function. So this is a C function I can call at any time that will just make my executable go away. It does a clean exit without any additional work. If I did get a valid key code and I've already been initialized, I wonder when this would be false. When is initialized set? What are you? Do I set that to true at the end of win main? Yeah, I do. Guess that's just in case like Windows decides to call my window proc before I've finished returning to the event loop for the first time. I don't think that can happen. I could probably get rid of these initialized checks. I strongly suspect. Maybe not, but I do kind of suspect I could. Because yeah, what would be in my event queue at creation time before I've even returned control to Windows? Nothing. That should be impossible. Okay, anyway, so that's some code I could probably remove. Where am I? This is key up. I was in key down. What else does this do? Right. If it's valid, I'm initialized, and I have a key code key down callback. I call it with the character code, the key code, the modifier flags, whether it's a key repeat or not, and that's how you detect that with this function and the current time. Some operating systems come with, so all of my input events get a timestamp here in this reference time parameter, the last one to them. Some event systems, I think everything except Windows actually does this. User events like a key down come with a timestamp of their own, which I can use for timing. Like for example, if my program's running super slow and I'm only returning to the event loop once every so often, and I want to get higher resolution input than that, like I want to know how far through my last run loop iteration a key was pressed, if that happened to take a long time. Can't do that in Windows because it just goes by the current time here, but event queue APIs that do include timestamps would give me something higher resolution here. But on Windows, it's just whatever the current time is. Anyway, Throw Rock doesn't care about that. It's not a real time. You need, like, I guess a rhythm game would be a good example of this. Like, if you're running at a lower frame rate, you'll still want to know the exact time at which an input was made, so you'll know where you are in the timing window for it. You know, that's an example of why that would matter. Run at a high enough frame rate and it'll be the same thing. So anyway, yeah, then I just handle modifier keys. Why is... When would this ever execute? Because I handle modifiers separately by polling the keyboard state. I don't think this code will ever execute. Yeah, I think this was an old way of handling modifiers before I had to pull that way for some reason, because this can't detect caps lock or something. Yeah, I suspect this will never execute because I've already handled modifiers. Okay, I could maybe delete this without losing anything. But yeah, if this is a left shift key down, then the left shift modifier key is now down, and I want to call this separate function I have for specifically modifier keys when that's changed. Anyway, because those have different semantics. WM syschar. So here's a thing that I've seen happen in a lot of Windows applications. Like Alt-Enter is a common key shortcut for toggling full screen. Whenever I do that in certain, like for example, the PlayStation emulator that I used for some games I did in the Final Fantasy streaming series, every time I'd toggle full screen in that, I'd hear this Windows beep sound. Beep. Because, and I always know exactly why that is, because in your window proc, you must not call def window proc if you get one of these messages. You don't got to process it or anything. But yeah, like Alt plus any key will generate a system beep if passed to def window proc. So you got to trap those and just not call the thing. A fun little nuance of Windows programming. Alt key presses which are handled by WM sys key down. Wait, so you're telling me if I've handled WM sys key down and returned 0 from here. Okay. So specifically if I have returned 0 after I've done a WM sys key down, claims this comment, which may or may not be accurate. I will assume I know what I was talking about when I wrote this. If I've returned 0 from this, I must return 0 from the subsequent one of these. So I just returned 0 from all of them because I never want the system to know about that, apparently. That could possibly cause me some problems if, for example, I had a system menu bar. I don't know, though, because I don't have one. Okay, anyway. So, key up and sys key up, again, just two different ways, two different messages depending on which key is pressed. Just does pretty much the reverse of key down. It's a little bit simpler. No character code is involved. That's only a key code. Because a character code is for the purpose of text insertion usually. You know, if I'm typing into a text field, I want to know the character there. But when I release the A key, I don't insert a character. So key up events don't include a character code because you just don't use it. It's not relevant to that. I guess I could do the same thing here for... Anyway, but I don't. Right, and there's a few others. So apparently WM activate app is both for foregrounding and backgrounding. That's if I do this and click outside the window. So that was activate app with apparently W param set to false because that's backgrounded. Then this is WM activate app with it set to true. So I pause the music, unpause the music, pause the music, unpause the music. Anyway, so that's all those do. WM close, so that's if I click the Windows close button, this message comes through. So that gives me a chance to say, hey, the user has initiated a window close. They want to quit the application. If this is a productivity application where there can be unsaved changes, when I want to defer closing the window, like, you know, I have unsaved changes here, I click, oh. Sublime Text doesn't work that way. It just closes and keeps all its state. Okay, fair enough. I guess you could also do that instead of preventing closure. All right, well, I do it the old way. I prevent closing the application if there are unsaved changes before dealing with them. In productivity applications that use that, this is a facility for that, which Thorock doesn't use. But if it had a level editor, I could imagine it doing that. Anyway, WM destroy. I guess that's sent as the last thing to the window proc if the window is being disposed. Post quit message 0. This looks like basically like tutorial code for how to set up a window proc that I just copied and left alone. I don't know how necessary this is. I don't know what this would do if I didn't handle this way. Oh, I see. This is, I could probably just call exit here. This is basically calling exit. It's probably the same thing. But maybe Windows does a little bit of additional cleanup from it. Yes, this is just saying if the window has been destroyed, then I'm quitting the application. Yeah, okay, no, that is necessary. Because otherwise it would stick around as a zombie with no windows in existence and keep on executing with nothing shown. Yeah, so this is how I say when the window has been closed, then the application exits. Okay, that makes sense. and I trap this one for some reason and return 0. Do I use this for something? I do. Okay. Yeah, so a user event is just something I can specify, so I can post to the window, hey, here's an event in your queue so that this function will get invoked and the event loop is woken up if for some reason they need to do that. And if it's not something that I've handled in that switch statement, I let Windows handle it this way. So that's how all input events come into a Windows application, and similar analogous stuff happens on other platforms. They come to the appropriate callback here in throw-rock code, and then get handled. Sure, we can take a quick look at, for example, key down. So if this is the enter key and the alt modifier is currently being held in the modifier's parameter, toggle full screen, and this is vestigial, not used in throw-rock, but it's there. Oh, here's a secret feature. If you want to take a screenshot in throw-rock at its native resolution, which is fairly small because the pixels are pretty large, you can save a ping with a file dialog with Control-Shift =. Ooh, I don't check for key repeat for full screen. Let's see what this looks like. Alt-Enter and hold-Enter. That's something. Okay, I can do that. I should probably check for key repeat there and discard it if it's not a fresh key press. Let's do that. Okay. So, that change has been made, because that probably shouldn't happen. Yeah, okay, so if I do this, I can Control-Shift =, opens up a, oh man, it's my directory full of thumbnails, all my secrets. Desktop screenshot.ping saves out at its native size that thing that was on the screen. So that was left over from Foresight Fight because that was a very useful thing to have in there. Right, yeah, the way this works is calls a shell function that opens a save dialog and calls some other functions that is stuff that I expect to maybe cover later. Might also just fall outside the scope of this postmortem. This has kind of turned from a postmortem into a here's how to program for Windows tutorial. Kinda. And I'm kinda okay with that. But yeah, I'll try and limit my scope at least a little bit here. So if it's none of those specially handled things, then I pass this on to, okay, right, there is some interpretation that needs to happen here. Okay, so there's another layer to this. I get the shell key code, but like if I get a key code X, that's not just pick up or throw rock. That could be mapped to anything. So there's another layer of interpretation here that determines which key mapping it is and then sends it to the right place to handle it. And we'll go over that in more detail later. But okay, I think that's almost fully covered all of the system stuff that needs to be talked about at initialization. We've almost gotten to the point where I've double-clicked this and we're here with this up and ready. So let's go super quick over the rest of it as far as like system API stuff is concerned, and all the future parts of this can be just game code and non-system API stuff. So at a very high level, target init initializes gamepads, sets up some callbacks for when gamepad events happen. So yeah, gamepad buttoned out. So there's a separate gamepad API that's not part of shell, but works similarly when a gamepad is attached or removed, or a button goes down or up, or an axis like a stick or a trigger or something is moved on the gamepad, then I get callbacks about it and can handle it as appropriate. Should be familiar by now. Initialize global objects, renderer, and game session is just sort of a repository of variables that the game needs to know about and keep track during its execution. I don't think there's much in there in Throw Rock. It's a bunch of leftover stuff from Foresight Fight. These are basically just globals, aren't they? Yeah, these could all just be globals instead of being wrapped up in an object, or vice versa. I could put all my globals in here and just use the global game session for it. Okay, it's just basically a container for global variables, more or less. Think of it that way. Renderer, oh, we will get to you, renderer. That's going to be fun. So a nuance about how I handle OpenGL, just very briefly covering this. I do not make any OpenGL calls in any actual game code. Those are all encapsulated in one single stem library, which would allow me to swap out graphics APIs, which is going to become important because OpenGL is falling out of favor on pretty much all platforms, except the web. There's still WebGL, and I don't know of a replacement for that one. Maybe there's Web Vulkan or something at this point, but yeah, so Vulkan on Linux, DirectX on Windows, Metal on the Mac, and iOS. I think Android also uses Vulkan. Yeah, so there is now another, I guess this always was the case for DirectX, but Windows was nice enough to also support OpenGL. But on pretty much all platforms, there is a graphics API, a GPU accelerated one, which is preferred over OpenGL, which I expect at some point to switch to. Therefore, it behooves me to have game code not make any OpenGL calls, because then I can just update my renderer library, and the games don't have to change. They just get a new implementation underneath that talks to a different graphics API that's more efficient or works better or is more compatible with newer stuff. So yeah, anyway, that's the principle that will be at play here. But we'll look at this in more detail in a future episode. This is more renderer stuff. This is setting up my the drawing canvas at this 1x size, which will then be scaled up to the entire window. So when I actually draw these sprites, it is at this size. Then this entire image, as composed of those tiny sprites, is scaled up. That's how that works. And yeah, this is just like state management stuff, gamepad stuff, audio stuff, sure. Where do I initialize audio? Do I not do that in... What is that? Audio player init, I think is the name. Okay, so that's deferred for a time. So some initialization happens in target init, but I save some for later because I want to, as quickly as possible, get the window up and start drawing something in it. So I initialize just the bare minimum number of things to do before I return control to the system. Yeah, so we'll go over all this when I talk about graphics. Timers, yeah, it'd be nice to talk about, but not now. Smartphone stuff, ignore that. If the preference to set the full screen mode is set, then I want to enter full screen mode immediately on startup. And then I call shell main loop. So this is the last thing I'm going to talk about today. Shell main loop is a function that is expected never to return unless the application is exiting. So the expected behavior of a user of shell is that at the end of target init you will call shell main loop, unless you want to just do a little bit of work and then exit right away. But usually if you want an application to stay up and receive user input and stuff, you call shell main loop. So that enters an infinite loop of processing messages from the system and passing them to the window to be handled by the window proc, I believe. So there's a little bit of initialization for if I'm doing multi-thread stuff. Yeah, that's right. That's important for multi-threading, which is... I think I have a separate audio thread as part of my audio API. So yeah, ThrowRock would be a multi-threaded application, just not anything in the game code, just supporting library stuff. I measure the start time. Why do I do that? That's right. For controlling... Okay, we'll get to that. So measure the start time. That's going to be an important reference value later. So peak message. If there is something in Windows's event queue for the window, then I want to pull it out with get message. If get message ever fails, that's a critical failure, and I just return for the main loop and exit the application. So this is error handling that shouldn't ever go off. Okay, right, and there's some complicated stuff for mouse move events. Just to go over it very briefly, I had to put a special thing in here. This is very recent and is not really relevant to throw rock, but I had another application using stem that did some hefty work whenever the mouse moved in certain circumstances, and I found that Windows sends mouse moved events at way too high a resolution. Like I get, 10 or 20 of them per 60th of a second. I'm making those numbers up, but it's something like that, like a lot of different mouse moved events, like, 1 pixel at a time. So it can be very high resolution. And if, in most cases, I would only want to know about the overall mouse movement between one frame and another. So this just coalesces those into a single message. It's kind of complicated for what it does, but that's what this code is doing here. But if it's not a mouse move message that has special handling here, then I called these Windows functions. This is just like what you do to pass the thing to the window. You just call get message to get a message, pass that message to translate message. I don't even know what this does. What does Microsoft say it does? Just out of curiosity, this link is purple. I've been here recently. Translates virtual key messages into character messages. Oh, that's interesting. I'm sure I knew this once, but I forgot. So, wait, really? So that's entirely about keyboard handling. If the message is WM key down, key up, sys key down, or sys key up, the return value is non-zero. Translation. If the message is not translated as a character message is not posted to the thread's message queue, the return value is 0. So it is that function call which causes a WM key down to put a WM char message into the queue. Well, that's fascinating. Okay. Good to know. All right, cool. Anyway, so that's what that does. Dispatch message is what actually, so somewhere in the implementation of this will involve the call to the window proc. So that's how the message gets to me after it's interpreted. Yeah, so this is a single struct that contains all the data that an event needs to know about, which gets unpacked in some way for window proc and turned into these 3 parameters, the last 3 to that. Anyway, yeah, so internal Windows stuff handles that. This is more mouse event coalescing, sure. So after I have emptied my event queue, basically like in between draws, I will have processed everything that's on the window. I'll issue a bunch of OpenGL calls to send something to the screen, then return back to this loop, and a bunch of more messages may have come in at that time, like the user's been moving the mouse, pressing keys, etc. So those just queue up. So Windows queues those up in the message queue for the window, and here's where I empty that queue. So this is a very deliberate thing that I have. And on some platforms, this just happens with callbacks. Like it handles its own, like on the Mac, for example, I just get a function call when a key has gone down. I don't have to go pull it out of the event queue and do all this manual handling myself. I kind of like it better this way, actually, but both ways work fine. Yeah, so those are just 2 different paradigms that this can be done with. And I just translate both of those to callbacks in my... I say I like it better this way, but I design my shell API to be callback based. Well, anyway, they have their merits. And just what matters here is that they are the same and that every operating system can translate from one to the other. Anyway, so then once my Windows message queue is empty, all events have been processed. Peak message returns false, so it has no more messages in its queue. I check what the current time is again, because some time might have gone by while... Well, actually, I don't have a time measurement up here. Yeah. Processing messages could have taken some time. I want a time measurement as close to timer handling as I can get it, because in addition to handling events, the main loop has a timer mechanism. So in here, I called this shell set timer function. Audio timer interval, what is that? That's going to be in shared definitions.h, probably. No, it's not. I'm always wrong about these things. Is it at the top of main.c? It is. Every half second I need to do something with audio? That seems surprisingly infrequent, but I guess I have a reason. Every 60th of a second I do something with gamepads. Every 5th of a second I do something else with gamepads? Okay. Anyway, there are periodic things that I want to happen at regular intervals. So I call shell set timer, which registers with the shell that on every return to the main loop here. When I say return to the main loop, I mean, like, for example, I guess I mean that the events have been emptied, but the event queue will at some point call target draw, hopefully every frame, and this function will return, and then this continues emptying the event queue. Then once that's empty, then I'm back here at the main run loop. That's what I mean. Anyway, yeah, so there are timers. Timer is just call this callback periodically. This handles that. It's a little complicated because there's a bunch of nuance to it, but yeah, basically just like I've installed a callback. Target init. I've installed the callback of audio timer here. Audio timer just needs to call audio player run. This is a thing. My audio API wants this to be called periodically to clean itself up and keep stuff going. And apparently once every half second is often enough. I forget how that works, but maybe we'll look at it in detail. So I can just register a callback to be called at a regular interval. It can repeat or not. If it doesn't repeat, it'll just get called once after that interval has passed when I'm here in this function. And if it was canceled, I remove it from the queue. Yeah, just simple list management here. And then I have a separate mechanism. I guess I could just set a timer for this, but there's like a lot of extra stuff to setting a timer. It's kind of complicated. I have a separate simple mechanism where I can say, what is it? Invoke, no, call on, oh boy, what it is it? Thread function, execute on main thread, there we go. So I can call shell execute on main thread. This is both for multi-threaded synchronization and for just saying, I have a function I want to be called once I've returned to the main run loop. If it's important for timing, I just add this to a queue. And then, yeah, that's what that particular mutex was for. Right, and in case the event loop is sleeping, I post that to wake it up. Where was I? Main loop. Yeah, so in case those are queued up, I empty them there and do those callbacks. And then we're kind of done. So if a shell post redisplay call has been made, since the last time target draw was called, which usually will be the case, unless I'm just sitting there not drawing anything. Like, I don't need to do a bunch of OpenGL calls and buffer swaps to waste CPU time if nothing's moving and nothing's drawing. So actually, no, in the case of throw rock, since I don't have continuous animation happening here or anything real time, like right now when I'm not moving my cursor, the screen's not being redrawn. No target draw is being called, no OpenGL buffer swaps are taking place. But as soon as I move and make a state change, there was one target draw there as I moved my mouse from here to here. Then if I move my character, 3 or 4 happen as that animation plays, and then it stops. So that's how that works. So that's based on whether I have called shell redisplay or not to say, hey, I'm going to need to redisplay again. Next time you come around to this, draw it again. And then this is some complicated stuff that I'm not sure I want to talk about in detail. At a very high level, I have an alternate mechanism where I don't actually vsync, but I still throttle my draw rate to once every 60th of a second or whatever I actually do check the display's refresh rate. So I request to be redrawn once every however many. Okay, so technically this has a minor bug in it. Let's say you had two displays connected and they had different refresh rates. Whichever one the window starts on will set its throttle rate, and if you move the window from one to the other, then the throttle rate will be wrong. Okay, so technically that's a bug in that super weird case. And there's some stuff that's important to think about. Anyway, yeah, so throttle the draw rate. There are reasons to do it this way instead of VSync. They're complicated, just as VSync is complicated, but I have both mechanisms. Because I don't want to just go as fast as possible. If VSync is off, and I have no throttling at all, then an application will just use all the CPU it can get. All your computer fans will turn on, and it'll sound very unhappy and unpleasant and get hot, and, you know, it's just not friendly to the system to do that. So I want some sort of throttling, and when VSync doesn't do the job, I have this alternate mechanism that calls a sleep function with some complicated logic to be sure it sleeps for the right amount of time. These are weird Windows functions that sort of work. Technically, this probably shouldn't affect you sleep, but it does. Yeah, so don't do what I'm doing here. Do your research better than I did. But this works for me on my computer. It's fine, I guess. Anyway, yeah, so these are Windows functions that I found. If I bracket my usleep call with them, gives me a higher resolution sleep time so I can sleep for the appropriate amount of time. Because Windows time measurement is kind of low resolution by default, but this briefly makes it high resolution. Anyway, that's weird stuff I've had to deal with. Redisplay needed. Redraw window. This posts the WM Paint message. Yeah, this just results in WM Paint being posted, so that ends with the target draw being called and OpenGL being updated and everything. And then, if no timers are running and no redisplay is needed, so we're just sitting there doing nothing in the event queue, then I can So the audio timer will always be running. So am I just doing a busy loop through this every... Well, no, I'm sleeping here because I'm throttling the draw rate. Oh, that's interesting. But only if redisplay is needed. Okay, this is curious. Anyway, what this does is, I think I have a slight bug here. This is not relinquishing control of the CPU as well as I'd like it to. If there are no timers running and the window is not being redisplayed, then wait, hold on. But this will always be false because I set it to false here if it's true, always. Or does this immediately do... Okay, one thing I don't know is whether redraw window just posts to the Windows event queue and then we go around to this, or if that actually calls the window proc with WM Paint. Redraw window. Let's find out. The redraw window function updates the specified rectangle or region in a Windows client area. How does it do that? By default, Windows affected return value remarks. When redraw window is used to invalidate part of the desktop window does not receive WM Paint message. To repaint the desktop, hold on, the desktop window. That doesn't apply to me. Okay, I would have to actually attach a debugger here to find out if it is the call of that function, which results in... Or hang on, no. There's a... this right here. No, I know about this. RDW update now causes the affected windows specified by whatever to receive WM Paint messages if necessary before the function returns. Okay, this is specified. So it is the call of redraw window that causes the WM Paint message to be sent. That can be sent by the system for other reasons, I think. Like if something has caused the window to be erased or something. That probably doesn't happen on a modern computer. but on an older one with a different compositor where like dragging one window over another would just actually erase its contents and have to call it to paint. But I suspect the like Windows 10 compositor doesn't do it that way. But yeah, this leaves the possibility of the system calling WM Paint while also doing it manually here. Okay, yeah, I gotcha. No erase. Yeah, don't bother actually erasing the window contents, because since I'm doing an OpenGL context, I will erase it as part of my redraw. That's probably to say, well, I can find out. Internal paint, I'm assuming that's update the content area and not the, regardless of whether any portion of the window is invalid. Right, I don't have to invalidate it first, but I also invalidate it. I wonder if that's necessary. Well, it's what I do. It's fine. That just makes me call validate, validate rect, validate window, whatever it is. Yeah, and actually call it a thing. Okay, so that is the way in which this could get set back to true, because target draw will indeed call shall redisplay again before it returns. Okay, so anyway. But if nothing is happening, if no redisplays are happening, if no timers are running, then this basically just sleeps until there's an event in the queue. But I'm looking at this and thinking, I should check my timers and wait an appropriate amount of time, not an infinite amount of time, but an appropriate amount of time to sleep before a timer goes off, instead of just busy looping right back to the beginning of this infinite loop here. That would be slightly friendlier on the CPU. I've measured CPU usage while these programs are... Have I done this on Windows? Maybe I haven't done this on Windows. Maybe my programs are wasting a lot of CPU time on Windows when they're not redrawing themselves. Yeah, I should do that. I should make it sleep for a little bit, kind of like my throttling mechanism here, if I'm waiting for timers. Yeah, just measure the shortest timer and sleep until that one is about to go off. Okay, that's a thing I should do. All right, so anyway, that's all of shell main loop. And I think that should be about all the time we'll spend in this shell file. There are other functions in here, like, you know, here are the details of what it takes to enter the full screen mode, for example. Exit full screen mode, we look to get current time. There's a bunch of other stuff, like how to find the file system path to the executable and its resources directory, which is where I keep the files I need to be able to load during execution of the program. This is for saving preferences and stuff. Yeah, okay, I can go over these super quick. Get main screen size, sure, get the screen resolution if you want to know it, number of displays connected, what display the window is on, display resolution again. Get main screen size. Okay, so this is a simple way to do get display bounds with a specific display if you just want to know about the main one. Huh, I wonder why I have those separate. Get refresh rate, we saw that briefly. Scale factor, yeah, Windows not implemented yet. We'll get there. I'll get there someday. DPI, if it knows about it. Safe window rect, we talked about that. Set timer, we talked about that. Cancel timer. Cursor management, get the mouse position, set the cursor, register custom cursor. I have a big mess here that doesn't actually work that I've actively been working on. Windows custom cursors just don't... oh man, I have all this stuff in here. Right, I was in the process of trying to get this to work. Windows custom cursors, hard to make work, as it turns out. I haven't figured it out yet. Mouse delta mode, you can open a URL in a browser if you want. Nowhere in ThrowRock do I have a clickable URL of my website. Maybe I should add one. That is the function that I would call if I wanted to do that. If you want to be like a full screen application that's nice to laptop users and shows them how much battery they have remaining, I have an API for getting the battery info, if you really want it. Which I've never used, but I added it for some reason. Usually I don't add things to this if I don't have a specific use case for it. I wonder why this was an exception to that. Anyway, but it's there if I want to do it. Multi-threading stuff, yeah, so thread APIs on each operating system are a bit different, so this does it with the Windows functions. I have a pthread-like API here that just does whatever each platform needs to do for it. Mutex, semaphore, etc. Execute on main thread, we talked about that. vsync, we talked about that. And now we're back down in the... oh yeah, and also there's file dialogues. We talked about that too. It says open file, open multiple file, choose folder, save file, clipboard management. A lot of this is just not relevant to ThrowRock. You can pull the modifier keys at any time, do a system beep if you want, set the window title, just a bunch of stuff. Okay, now I think we're back down in familiar territory. Yeah, so this is event handling stuff. Yeah, and that's pretty much the entirety of WGL shell. Pretty much. Close enough. I summarized a lot of parts of that, but I'm trying to stick to some relevance. Okay, so next time, I think we can get into the actual game code and how it's organized. Unless I want to talk about renderer stuff, maybe I can do some of both. We'll see what makes sense. But yeah, so at this point, the system has initialized itself. We've gone through everything that happens between this double click and that showing up. So there's a bunch of stuff to talk about in like how it loads this level and sets up its input map and all of that, those game-specific details. But all the game non-specific details I think have been covered now. All right, so game-specific details happening next time, and I'll see you for that.